Wow, have you started doing astronomy?
Yeah, I've signed up to the school astro club. This way I'll have my instruments.
Cool, and what can you observe with that one?
The Moon, Mars, Jupiter, Saturn, extrasolar planets.
Huh?
You know extrasolar planets? You're supposed to make a presentation about detecting them.
Oh, forget it. I don't have time, and moreover, I wouldn't know where to begin.
Lucky you found the specialist. By the way, how is your transit?
What?
Alright, first up, the first extrasolar planet was discovered in 1995 at the Haute-Provence Observatory. Secondly, there are over 3,000 of them detected today.
Okay, let's settle for 3,000. Don't you want to see it?
What is an extrasolar planet? It's a planet that rotates around the star, its sun.
I know, thanks for filling me in.
Okay, but here we are talking about planets and stars that are outside the solar system, light years away from us.
You're gonna bring up your Proxima Centauri b again.
Yes, or another one, Mr. Jaded. And how do you detect them, among other things? The transit.
You're obsessed with transit, aren't you?
Look here. The transit is a method for detecting planets. With luck, one can see the planet pass in front of the star, and so the luminosity of the star decreases because the planet hides part of the starlight, and then the luminosity gets back to normal and presto decreases again when the planet comes back. On top of that, its radius can be measured.
Call you transit.
There is another method, that of radial velocities.
You studied before I got here, or what?
I told you, I love this topic. In fact, the planet doesn't really rotate around the star, but around their common center of mass, and so does the star. Are you following me?
Okay.
This means that even if we can't see the planet, we can measure the periodic movement of the star, and so we can compute the mass of the planet. You're not saying anything.
I have to admit, I'm speechless.
You bet. I'm glad to see you're interested in my extrasolar planet now.
Toads! And do you know what types of extrasolar planet can be found?
You're asking the specialist, lucky you. If you know the mass and the radius of your planet, you can compute its density. Here you go. A gaseous planet, not very dense, and there, a rocky one, let's say 5 times denser than the gaseous one.
Okay, your gaseous planet may be less dense, but it's got a bigger volume, Monsieur Specialist.
Just imagine, light years away, a planet turning around the Sun, 5 times more massive than the Earth, and where there might be life.
Wow, trans you! Well, if you really think about it, for life to exist on your extrasolar planet, your super Earth, you need exceptional conditions.
Yep.
It must be habitable.
I have to explain everything to you today. If your extrasolar planet is too close to its star, it's too hot. There is no liquid water, so no life. Are you following?
Give me a break, I'm not that stupid.
If your extrasolar planet is too far away, it's cold, like super cold. Your water will be ice, not good for life. So, we need to find the right middle way for water to be liquid. That zone is called habitable zone.
Your habitable zone. Okay, but how can you detect life on an extrasolar planet that's light years away? You won't go there with a test tube.
By studying its atmosphere, I suppose, if there is one.
Oh yeah, but it must be super difficult.
Yes, but with a new generation of telescope, we will be able to make progress. We'll start with probing the atmosphere of giant extrasolar planets, Jupiter-like, to understand them better. In parallel, we'll keep developing instruments to detect water in the atmosphere of small planets. Detecting water, I love that!
So, you won't find life anytime soon. You need to find a rocky planet, like a super Earth, with an atmosphere around it to be probed.
You have a point, but we can remain optimistic. By the way, you could end your presentation by talking about Plato, a satellite with 26 cameras that will be launched in 2026 to search for and study rocky extrasolar planets around stars like the Sun.
You totally inhabited it today.
I am indeed. This one here, we don't know yet.